Hello, welcome to my tutorial on making your first game, specifically in the Godot game engine. All the resources you will need for the platforming game will be found here in my GitHub, which I have linked in the description below. Now, as soon as you have that downloaded, it's time to get right into it. Welcome to the Project Manager. It will be the home to all of your projects, whether the project is finished, in progress, or abandoned for something better. From here is where we will create our first game. To get started, press the Create button. From here, a new window will prompt you to not only name your project, but to select the directory of your choosing to store your project. For me, this will be in the Documents folder, and for the title, name it whatever you'd like, but I will name it First Game. Then press Create and Edit. Welcome to the heart of the Godot game engine, the editor. Now, let me give you a brief tour on all these tabs and windows so you don't get too overwhelmed late in the tutorial. In the top left, you have 5 drop-down menus. The Scenes tab. This allows you to manage your game's scenes. Scenes in Godot act exactly like classes do in many programming languages. They are used to encapsulate multiple methods and nodes. Nodes act like subclasses, which all can have their own methods, but generally the parent node is the only one which has any code attached to it. The parent node being the first node in the scene where all other nodes are added onto. Next, we have the Project tab. The Project tab is used to manage your project settings, from the size of your screen that the player will see to how your game will render textures and objects. Next, we have the Debug menu. The Debug tab contains useful tools and other options that will allow you to figure out bugs within your game and where potential issues might occur. Next, we have the Editor tab. The Editor tab allows you to customize your editor to your heart's content, allowing you to do things such as customizing the color of your UI or whatever font you'd like to use within the editor, and so much more. Lastly, we have the Help tab. The Help tab will be a useful tool for anyone new to Godot and game development in general. Be prepared to spend many hours reading through the entire Engine document in order to understand all the issues you'll be running into while developing your games. Next, we have the top right corner. We have the project controls, which allow us to run, pause, and close your game. In the center, we have 4 tabs which control what we see in the central window of our editor. 2 tabs change our viewport's perspective. The next tab is the Script tab. The Script tab is an inbuilt IDE, which allows us to easily program our game using GD script. Finally, the Asset Lib tab, short for Asset Library tab, which is where you can find templates, game demos, projects, plugins, and all sorts of useful assets, which I recommend you explore in your own time, as it is outside of the scope of this tutorial. So, click on the 2D tab. In Godot, 2D scenes are laid on a plane with an x and a y axis, similar to the Cartesian planes we had in school, but with one key difference. Above the x-axis, y is negative. Below the x-axis, y is positive. Otherwise, the x-axis remains unchanged. Left of the x-axis is negative, right of the x-axis is positive. Now, let's add the assets we'll need uh, for our game. In the bottom left, we have the res directory, short for resource directory. Unzip the provided files from the link below and drag the unzipped files into the window and wait for the assets to be imported. Alright, now let's actually get to making something. We'll first start with the player, the user's way to explore the game world we will be building. In the node window, press the plus symbol or Control A to create a new node into our empty scene. I briefly brushed over what nodes and scenes are, but to hopefully demystify both terms, I will explain roughly how they work. Scenes are collections of related nodes that form complex systems. Nodes form the behaviors of their nodes inherit the behaviors of their parent nodes, which combine in a scene to form mechanics. Nodes within the node tree inherit the behaviors and properties of their parent nodes within the node tree. To visualize this, look at the character body 2D node we've just created. We can see the node 2D is a child of node and node 2D. But along with this, it inherits a collision object 2D and a physics object 2D, which means it inherits both the physics property and the collision property of the node 2D node. As an example, the reason we've created a character body 2D is because we need the node to be affected by physics processes like gravity and can move in the game world. Now, now save. You'll be prompted. To select a save location and a name. Create a folder to save your scenes, as we will for scripts later. Right click, new folder, scenes. Okay, and we shall rename this to player.tcsn. On top of this, let's rename the node by double clicking on the tag and also renaming it to player. There. This alone isn't enough. We need something to make sure our player doesn't fall through the floor. We need something to make collisions possible. Thankfully, the smart people at the Godot office has given us nodes to do everything, including collisions. Add another node called a collision shape 2D node as a child of the player node. Click on the player node, press the plus, and type in collision shape 2D. Press enter. Don't worry about the error we have there now. We'll fix that later. Now, as you can see, we can't see our player. We will need to add an animated sprite 2D as a child of the player node to give it a sprite for the players to see. Please make sure you don't make the animated sprite 2D node a child of the collision shape, or else we run into errors. Click on the player node, press the add or control A, and write animated sprite 2D. Alright, now that we have the animated sprite 2D node, click on it and then go to the right to the inspector. Now under the inspector, click on the animations dropdown and we will have 4 options. Now click on sprite frames, new sprite frame, and click on the new sprite frame button. From here, the animations window will pop up below. This is where we can handle all of the animations that will be associated with our character's movement within the game. Now, we will need 3 animations in total for the player. 1 for jumping, 1 for movement, and 1 for when the player is idle. Let's rename this one to idle. Now, go to the game assets folder, then head to sprites, expand the sprites, player, and select all the images which have idle number.png. Click and drag them into the empty window and watch as the 2 sprites come in. Now, you will see that our character looks a little blurry. This is thanks to the Godot and editor's rendering. In order to fix this and see our pixel art nice and crisp, we need to change the rendering from linear to nearest. To do that, click on the project settings, textures, and go from linear to nearest. Click close. And now our character is nicely defined without any blurring. Let's add the other 2 animations. Let's add the left animation, and finally, let's add the jump animation. Now, you might be a little confused on why we only have an animation going to the left. That's because the animated sprite 2D has a special property which can allow us to make left animations flip horizontally to look like right animations. To do this, we go under the Offset tab, and there's something called the flip H, flip horizontal. When it is true, the animation will flip to the right and it will play correctly. we can control and see what our sprites will look like using the controls provided to us above. We can see the jump animation at work, the idle animation at work, and the left animation at work. You can tweak these to how you see fit within the game world. Now, while we're here, let's also change the viewport settings. The reason for this is that when adding a scrolling background later using the parallax node, you always want the width of your window to match the width of your background image, which in this case will be 600 pixels wide. And while we're here, let's also change the viewport size. The reason for this is when we want to add a scrolling parallax background later with a parallax node, we need the width of our window to match the width of the background image. In this case, the width of the background image is 124 by 124 pixels. To do that, go to Project, Project Settings, Window, and in the Window Width section, change this to 124. Enter. Close. Now that we finally have a visual representation of our player, we will finally be able to correct the error we had before with the collision shape 2D. Now that we can see the bounds we are supposed to set the player to. Click on the collision shape 2D node and head to the inspector. In here we have to select the shape of the collision or the collider. The collider acts like an area in which the node will be affected by collisions. In this case, we want the capsule shape 2D node. Remember not to make the collision shape too large, as we want to give our players some leeway to make sure the game isn't too unfair. Click Ctrl S to save, and now finally, we can add a camera 2D node as a child of the player node. This will ensure that the camera follows the player as they go across the scene. Click on the player node, Ctrl A, camera 2D, enter. There's our camera 2D node. Now, since we had to add sounds to our player when they jump or collect a coin, we need to add a new node called an audio stream 2D. We need two of them actually, one for jumping and one for dying. Click on the player once more, Control A, and then we can simply write audio stream player 2D. Remember, we have to add two of them. Audio stream player 2D. And let's name them appropriately. We'll name the one jump sound, and we'll name the other one death sound. Now that we have these two audio stream 2Ds, we can finally add sound to it. Click on the jump sound node and head to the inspector. You'll see there's going to be an empty class next to the stream. To add sound, go back to our Assets tab, go to the SFX folder, and since we have selected the jump sound node, we click on the jump.wave and drag it into the empty box. You'll see it'll be highlighted by a blue window. In Godot, that generally means it'll accept that file type. Now, let go and watch it be attached. We'll do the same for the death sound. Now, the last node that we will be adding to the player node is going to be a timer. A timer node acts just like that. It'll count down and reset, and based on when it times out, we'll be able to do certain things. Press on the Control A and write timer. We will call this death timer, as we want time between the player colliding with an enemy and before the the game reloads, as we also want the death sound to have time to take place. So we'll simply name it death timer, and that's that. Let's out our first and only script we need for the player. Click on the node and look in the scene window. You see, click on the button with the little piece of paper and a green cross. Click on the click on it. Now a window will pop up to prompt you about the template it uses and the path you'd like for it. Just like we did for the scenes, we want to create a folder for the scripts. So open the folder, go back in the path, right click, new folder, scripts, and press enter. Press enter again, and that'll be our script. Finally, click create. But make sure you have the basic movement template selected, because this will greatly shorten the amount of work you have to do. Click create. Who said game dev was hard? We've been given the basic code we need for a platformer, along with the set gravity, set jump velocity, and all sorts of processes to help our game work. Now, let me try and explain the code that the editor has provided with us so that we are able to alter it to fit what we'd like later. Okay, let's start from top to bottom. Here we have constant variables. The word constant and the word variable seem to juxtapose one another, but in this case it makes sense. If you're familiar with programming, you know a constant is a variable that can't be changed within the course of the program running. For those who don't know, that's the basic explanation of it. A variable is sort of a box which you can place a value into and retrieve and change later. A constant is like a variable which you put something in and you tape it over, because then you can't take or remove something from the box while it is closed. Now, we have a constant for the speed, and we have a constant for something called jump velocity. As you can see, the jump velocity is negative, and normally that'd be unintuitive, as that means that they'd go into the ground. But remember what I explained before. In Godot, upwards is negative y and downwards is positive y. So it makes sense. Now we have our first example of a function in Godot. And not only that, a special function which Godot provides. The underscore physics process or underscore physics underscore process is an inbuilt function within the Godot game engine. The physics process calculates not only what code we give it, it also calculates physics calculations based on its own supplied methods that we don't have access to. And you can see something within the brackets called delta. Delta, you can think of delta as the time between a frame being rendered. As you see, delta is incredibly useful. On the surface, this sounds like an arbitrary measure of measurement. But when it comes to games, having a delta function greatly increases the compatibility you can have between different systems. You see, when it comes to movement, for example, you want to multiply it by delta. That just ensures that on different frame rates, on different machines, the game will run at the same speed. You might not necessarily always have to measure by delta, and it might not necessarily be the best practice, but from what I've experienced, multiplying by delta is the safe way to go. All right. As you can also see, a nice function of GDScript is that you don't have brackets. Instead, code blocks are defined by indents. And on top of that, you don't need to add a semicolon at the end of lines. The only time you have to add any sort of additional script or additional character is at the end of things like functions, or in this case, arguments like if, which is what we'll go to now. If you're experienced with programming, you know what if is. If is a argument. based on something being true or false. Oh, one last feature of the physics process. It runs every frame. That means that everything contained within this code block is being run every single time a frame is rendered. So keep in mind what you put within the physics process. If something doesn't need to be rendered every frame, don't put it in the physics process. Or at the very least, make sure there's an argument which prevents it from being run when it isn't necessary. Having your whole script running in the physics process, checking through various arguments, will greatly reduce the performance of a program. So please keep a good programming etiquette in mind for your own sake. All right, back to the if argument. So if determines if something is true or not. If this statement is true, this will run. If this statement is false, this won't run and it will automatically skip to the next argument or the next code block. Now, here the if is given the argument not is on floor. Is on floor is another provided function or method by the Godot aim engine. It checks whether our physics or character body 2D object is sitting on top of a flat surface, which is called is on floor, i.e. the velocity going downwards isn't positive. Now, if the player isn't on the floor, then the velocity downward will be another provided process. This is special. Well, let me break this down. Velocity. Every physics body will have a velocity variable. It is provided as a part of the node's properties. So, if the player is not on the floor, we want to add upon the negative or the positive velocity downwards, because remember downwards is positive in Godot. We want to multiply by something get gravity by delta. Get gravity is another inbuilt method. Get gravity has to deal with the project settings dealt here. This is linked with the physics engine I was telling you before. To edit the gravity, simply go into the project settings, write gravity, and under physics 2D, and you can set the gravity to your liking. Now, those of you who have taken physics will see that 980 looks similar to the gravity constant on Earth of 9.8 meters per second squared. But let's not bore you with the science right now. We will change this later to allow our player to jump to greater lengths, but that will be covered a little later. Now let's explain the rest of the code. We have another if argument. Here we can now see a few other functions. We can see a familiar function is on floor. But another method that we haven't seen before, or two even, input dot is action just pressed UI accept. Alright, let's break this down. Input is a base method of Godot. It handles the input and output of your game engine. So, and the method of input being used is action just pressed. It checks to see if you've pressed the button, simply. UI accept in this case is the spacebar. So, if the spacebar has been pressed, and so when it comes to arguments, if you're familiar with arguments, you know that both of these statements have to be true for this code block to run. If you're unfamiliar with programming, all it simply means is that these statements have to be both true simultaneously for this code block to run. Now, we can read this. Velocity.y is equal to jump velocity. All this is doing is setting the jump velocity to the constant, which means it'll have a positive velocity a negative velocity of 400, which is upwards. Now, this is the movement code. Here we can see our first example of a true variable, a variable which can be changed. So it is called direction. Remember how before I said that on everything right of the y-axis is positive and anything left of the y-axis is negative. This is useful because because it helps us be able to program movement. See, input, we've seen that before, get axis. So get axis is another inbuilt method of the input method, or the input class, we should say. It gets the quote unquote direction of your input. You see, there's four axes really in Godot when it comes to vectors. There's an X and a Y in the 2D plane. All it is checking to see is that left will be -1 and right will be +1. So if you're pressing right, direction will be equal to 1. If you're pressing left, direction will be equal to -1. And if we have a direction, the velocity in the x-axis will be multiplied by direction times the speed. But you can see here they didn't multiply by delta. So let's fix that. All right. And we can see else velocity equals move toward nothing. So if we don't have a direction, if the direction is 0, or there is no input, we want the velocity to slowly move towards 0 from the speed we've given it. And now the last inbuilt function, move and slide. Without this one line of code, your object won't move at all. This basically handles everything when it comes to movement. It registers the movement on your screen. All right. Now that is all I have to explain for the code they've provided. But now we have to adjust the code for our own purposes. For example, let's say you don't only want to use the arrow keys for left, right, and the space bar for jumping. To change or to create our own custom inputs, you simply go to Project, Project Settings, Input Map. Here we go. Now, to add an action, you simply describe what the action is in its name and press Add. All right, now we have the left action. I want A and the arrow key to be left. To do that, you press on the X next to the action and press A. And to add additional input users, press the plus again and press left. Now, do this for all your controls, and when you're done, we'll continue. As you can see, I've done that off screen, but here we go. Now click close. Now, if we want to implement it, it's very simple. You see how is action just pressed for the jump handling? We can now press Control Space. Control Space allows the smart completion to come up, and you simply write what you had before. I think I wrote up. Up is what I used. And now to change UI left and UI right, you simply write left or whatever you set for left and right or whatever you set to right. And there we go. Now, there's not much sense in actually creating or actually running the game now, as our character will fall infinitely downwards. Although we might not see it because there's no background, we can actually do something to show that. What we can do is click print and our velocity dot y. As you can see, our velocity.y is increasing. That means we're falling downwards. And as you can see, the computer is struggling to render the speed at which the character is going. Let's exit. All right. Now, I want to add a death function for when our player collides with the enemies later. To do that, we simply write func death brackets semicolon, and space. For now, we'll set that to pass. As you see, I've already added a death variable, and it's starting to have an issue with the function of death. So you can simply write capital D and the error should clear. Yes. All right. Now, this is going to be important for later when we actually add the enemy. But let's add the code now. Remember, if the player is in the death state, we don't want them moving at all. So, to change that, all we really have to do is add to the arguments we've had below. See, in addition for us having to have press space and for us having to be on the floor, we can simply write and death has to be equal to true. All right, so let me clear something else when it comes to Godot. In Godot, like many other programming languages, a single equal it doesn't mean equality. It doesn't mean that one side is equal to another. In Godot and in other programming languages, this is simply called an assignment operator. It means that a variable has been given a value on the other side. All right. Now, we are testing if the death variable is true. Oh, we should actually make it false. Or else we'd always be dead and we'd never be able to jump. So, if the action we've pressed is up and we are on the floor and the player isn't dead, we can jump. Now, let's add something similar for our movement in left and right. All right, cool. Now, all we have to do is add an extra argument of your own. If you'd like to give it a hand yourself, please pause the video and try it yourself. All right. Now I'll give you the code on how to do it. If death is equal to false, now we simply just have to indent all of the code we were given below. And there you go. Now the player can't move if they're dead. But we also want to handle the player's animations because right now the player doesn't move, the animation doesn't change. And although we can't see that effect right now, we can see it forward. All right. Now, all right. So, let's try and handle the player's movement. So, we want the player to only move left and right while they're on the ground, firstly, because we want the special jump animation to play otherwise. So, let's create the statements or the arguments that'll help us do just that. So, if we're moving, so let's explain this mathematically or in the way that we're going to program it. If our player is moving left, so let's select our player. If our player is moving to the left, we can see the left of the x-axis is negative. So the direction will be -1. So all we have to do is say or check if the velocity of the x-axis is less than 0, the animation will be facing the left. And if the animation is going to the right, then we have to see if the velocity.x is greater than 0. And on top of this, we have to make sure that when the player isn't pressing anything, that the idle animation is playing. All right. Now, go back into the scripting window by clicking on the little piece of paper, and let's begin to program it. So, like we said before, if the velocity dot x, or the x component of the velocity, is greater than 0 and the player is on the floor, we can play the animation. Okay, now let me explain another concept. The $sign is the get operator. You see, we want to interact with the other nodes with under the player's function. To do this in Godot, you write a $sign and the name of the node. So in this case, we want to change the animated sprite 2D. We want to affect that. So dollar animated sprite dot 2D dot play left. All right. But as we discussed before, anything greater than 0 is moving to the right. This is where that property of the animated sprite 2D comes to play and halves the work we have to do when creating assets. We do the same thing, we get the animated sprite.2D node, and we say dot flip h is equal to true. So you see, as you can see here, we can not only access the default methods or functions of a node, we can also affect the individual properties. You see, the flip v, as we saw before, is an actual property that we have here. There. Now, let's add the movement if the velocity is less than 0. We simply write elif velocity dot x is less than 0 and is on the floor. Now we do the exact same thing when it comes to playing the animation, but we set the animated slides flip horizontal property to false, or else you'll be looking right and it won't make sense. Now, finally, we need to make the code for when the player is idle. To do that, I recommend you try it for yourself. I'll give you a few seconds. Pause the video if you'd like. Yeah. All right. So, if elif velocity is dot x is equal to 0. Actually, we should set the entire... no, this is fine. And is on floor. Now we can say animated sprite dot play idle. And we have to make sure that it hasn't been flipped horizontally. Even though it's a small detail, we should just do it anyway for clarity. All right, now we have the movement code implemented. On top of that, let's also add something here. So, when the player dies, we want we want the game to reset. So, in order to do that, okay, we'll be doing this in time with the timer. We'll actually use the timer and we'll actually get to see how we can interact with the node tab and all of these inbuilt functions or methods. So, when the player gets hit by the enemy, we want it to play the death sound. So, I'll give you a second to try and do it by yourselves, as now you should be able to have the ability to try for yourself anyway. So, I'll give you a few seconds. All right. So, what you have to do is you have to get the death sound player dot play. All right. Now, it'll play the sound we've given it. But on top of that, Remember, we have a timer so that after the player dies, we give it 1 second of time to let the sound play before we move on to the next function. So we should now start that timer. So death timer dot start. Finally, we should set dead to true to stop the player from moving. But now you might ask, okay, we've we've already set we've already set excuse me. Um, Now you see, um, we've done everything to show that the player is dead except restarting the level. Now, this is where that timer comes in. You see, most nodes in Godot have special inbuilt functions under the Nodes tab by the inspection window. And you can see that most nodes, all nodes actually, as I explained before, the children will inherit the previous nodes of which they're contained in. So all of them will have a node and an object properties, but the timer has a special method called timeout. So the timeout method appears once the timer we started, so once 1 second has elapsed since we've died, will then release a signal or start the function called timeout. So to actually use this node, we have to click, this method, you have to click on it and click on connect. From here, you must click on the player. It'll give the receiver method or the name which we'll give it, and we'll click connect. Bah. And all we have to do to reset the level is, excuse me, get underscore tree dot reload current scene. So that might not mean a lot right now, but let's describe it. So get tree. Get tree gets the highest, gets the parent node, the highest node of all the scenes and nodes in a scene. And dot reload current scene basically means we reset all the values to the starting values. All right. Now, that is almost all we have to do for the player. All we have to do now is add the player to a scene group. All this does is allow us to access any of the player's scene methods from other nodes and scripts within our game, which will be useful later, so that we can actually run this death method. So simply go back to the inspector, click on node and group. Sorry, I made a little error. Click on the player node, the parent node, then press the plus, then name it player. All right. Okay, now let's create the level scene. First save. Okay, click on the scene tab and new scene. Boop. And now let's add a 2D node to be the parent. 2D. Or we should just write node 2D. Click on it, create, and let's rename it to level. Now let's save it. Let's save it in level.tcsn, and we are Gucci. All right. Now, our level has to perform 6 functions. It has to provide a scrolling background called a parallax background, which is a parallax 2D node. We have to provide platforms and a floor for our enemy and play to stand on. We have to play the game's music. We have to kill the player if they fall. And we have to use it as a way for nodes to communicate to one another. All right. So let's get started creating the level. So to create the scrolling background we were talking about before, you simply add a new node, look for parallax, parallax parallax 2D or parallax background. Create. And we need something called a parallax layer, because parallax backgrounds can have multiple layers to give different effects, but in this tutorial we'll only have one. And we have to give that parallax layer an image so that it can actually display the background. To do that, we use a sprite 2D, not an animated sprite 2D, because a background is meant to be pretty much static, at least for our purposes. Now, to actually give, let's go into the 2D tab, click Save. To actually give this sprite an image, you click on the sprite 2D, head to the inspector, and you'll see an empty texture. To add a texture, you simply go under Sprites, Backgrounds, Expand, click and drag, and there you go. Now we have the background. But that's not all. We have to make sure that this background repeats whenever the player gets near the edge. To do this, we go to the parallax layer, motion, and the mirroring. To this, we also have to set to the width that we set in the viewport control, which is 124. And as you can see, it'll repeat horizontally every 124 pixels. But to also make sure that it's not too boring when we fall off, let's also set the y-axis to 124. All right, cool. Now, on top of this, we actually want a platform for the player to stand on and the floor for the player to not fall through. To do this, we simply have to add something called a tile map layer. So, to explain what the tile map is, it, in essence, is a single image which contains different parts or different sprites for different backgrounds, objects, all of the sorts. So, to do that, Control A and add a tile map layer. Before we used to have something called the tile map, but it's no longer being supported. So, tile map layer. Awesome. Now we can see it requires a tile set. Okay. Or we have a tile set provided. We also have the individual files, but we should tackle everything with the tile set. So, click, drag, oh, boop, new tile set first, click, nothing there we really need, and click, tile set, click, drag, and no, we want to create our own atlas, or else things will get a little bit messy. All right, so by default, you will see that it's segmented into different shapes. So let's see here. 16 by, okay, you see the texture regions are 16 by 16, but these images are specifically 32 by 32. To fix this, all we have to do is just do 32 by 32. And there you go. Now each block is individually spaced. So now we have new tiles. But these can't collide with anything yet, which is a problem. But we can fix this. In order to give our tile map a physics body for it to use, all we really have to do is give it its own physics layer. To add a physics layer, which is what we'll need to actually paint the textures on, click on the tile set, get to the physics layers and add element. Let's just give it the same physics layer that our player will have, which is 1. Save, and now it is just time to actually give these physics. So, by default, it'll give us this little square. As you can see, it doesn't fit the entire square, or doesn't fit the entire tile, which isn't useful. Expand and drag these to the corner. like so. Ba-ba. Let's add grid snap to make life just that bit easier and delete this extra node we've created. Add, click on this. Uh-oh. Oh no. Oh, nope, sorry. Delete. We just simply want to move it. There you go. And now it'll snap perfectly into a square for us to use. Cool. Now that we have this shape selected, we can now paint it onto all the square blocks simply by clicking. Boop, boop. Now those all have physics. But we have to make a new paint layer for this platform because it isn't a square. To do that, we'll do just the same thing again. We will just change the snap to half pixel. We'll zoom in and we'll just roughly fit it to what we'd like. Drag it down, drag it up, drag it up, and drag that down. Cool. Collapse and click, and there we go. Now, the really cool thing about tile maps is that you can paint on your level basically. Go to tile map, and now you have the tile base. So, click on a tile you want and paint to your heart's content. So, ooh, oh, sorry. Beep, beep, beep. Boop, boop. All right. Now, you can see this is perhaps a little small. Now, this is where our other properties come into play. We can actually edit the size of a node with a scale. So for this tutorial, we'll just use 3 since it makes the most sense. And there you go. Now let's just create a little basic platform. Create it however you'd like and make sure there's a space at the end for where we're going to collect the coin or the win condition. Oh, one last thing. We have to make sure that they're spaced from one another correctly. So we just make the tile size 32 by 32. And now we shouldn't have any issues with tiles not clicking correctly. There you go. All right. Now, I'm assuming you've created your own level, but let's actually test out what we have. So, to add the player as a child of the level node, or to have the player accessible within the level, you have to press the instance button. This looks like a chain link sort of, or you can press Control Shift and A. We add the player.tcsn and boom, here is our little player. But as we did with the tiles, you also will have to make sure that the player is larger. So times 3. And there you go. Now, let's test it out. This is the first time we'll actually be able to play the game. Here is where we will actually edit properties of the player so that it better fits. Let's see. Running the... Oh, wait. We're not playing this node. Ooh. Now, we have to play the current node. So run the current scene. All right, we have our player, but as you can see, he moves incredibly slowly. This is due to us increasing his size and not the speed at which he moves at. So, now, let us change that. Boop. And head to the player, head to the script, and let's just bump up his speed to something like 7,000. Why not? It doesn't matter. So, well, it does matter, but wrong scene once more. Level, play current scene, and there you go. Our player can now move. We should probably make him a little faster. We should probably edit the layers once more. We should probably set the viewport width correctly. And there you go. Yeah. Oh, okay. So to fix the issue we had before, we have to make sure that the parallax level or parallax layer is actually where we want it to be. Let's reopen that. Scenes level. Okay, let's just double click. We actually have to move the sprite in line with the level. So line the leftmost edge with the y-axis on the right side of the y-axis, and that should fix everything. And for the sake of not having our player run like a snail, let's just up his speed to 14,000. Wrong scene. Awesome. Opa. And there we go. He's moving at a decent speed, and everything seems right with the world. But his jump velocity is too low. So let's change that as well. To change the jump velocity, we simply go here, and let's just give him 1,000 jump velocity. And see what will happen. We don't do that. That is the wrong way to do it. But we can just, woo! A bit ridiculous. Probably need a little less. Let's say 600. Давай. Hey, and there we go. He jumps high enough to get onto the platforms. And now all we have to do is add the jump animation, which I forgot to add. So let's return to the player and add just that. So up. As you can see, we still have the if not is on floor. So animated sprite dot play. And we just say the jump animation. Now, when he isn't on the floor, he'll go flying. So let's do that again. Yay, there you go. But you see, he's flipping a little slow. That's the amazing thing about game development. You can change whatever you like, whenever you'd like. So let's do just that. Let's up this to 10 now, and let's slow this down by 2. Now, FPS is how many of these frames are went through per second. So let's go see. Does this look any better? Not like that. Yeah. Again, same mistake. Welcome to game development. But here we go. He's playing his idle animation when he's still. The left and right animations work, and when he jumps, he does a little somersault. Awesome. Now, all that's left to do is add the enemy and the win condition. So, let's get right to it. But remember, nothing happens when the player falls off. He falls infinitely. So, to fix this, let's give our level a boundary. So, click add an area 2D node, and an area 2D node basically checks if there's any collisions within its square. To do that, you create an area 2D node, and an area 2D node, just like a character body 2D, needs a collision shape, or else it can't work properly. So, add the collision shape. But we can't use any old collision shape, because having to make a giant collider under your map isn't practical. But there's a special type of shape called a new world boundary. That means anything that goes beyond the boundaries of this will be detected. All right. Are you ready to make the second script? Let's call this death area. All right. Now, just like before, you can go into the area 2D node. And just like before, there's so many inbuilt methods. But now we can do something special. With this area 2D node, we can see if the player has fallen and is detected within the border boundary. To do this, you can either use a area shape or a body entered. In this case, we'll use a body entered. Uh, we should also probably set our tile maps collision to false because oh wait, no, tile. No, yeah, no, never mind. So to do that, we simply click on the area 2D and body entered. Connect, and let's connect it to the player as it should be handling all of the communication between nodes. Connect. Up. So, what's the issue here now? Connecting from. All right. Connecting to. Target method not found. Ooh, not good. Connect. It wants to connect to the player. Interesting. Well, uh, hmm. Actually, this is good. So, whenever the player enters this area, we can simply run the death function. This will prevent us from adding another scene, which will give us extra work. So, connect, and on death body entered, you simply run the death function. Awesome. Now, let's see if it'll work or if we have to maybe finagle a bit more and see what'll happen. So, he falls off. Ah, he died. And there you go. We can see that the death function is working properly, the world boundary is working properly, and that's all we need from that. But the game is a bit bland. We can't hear anything, we don't see anything, and we don't hear the jump. So let's finally add some sounds. So let's go back to the player code, and we can say, uh, yeah, animated sprite 2D dot play jump. But we also only want the jump to only play once. We don't want to constantly hear the player jumping over and over and over again, correct? Because that's not fun. So, um, to fix that, so uh, we want the player to actually hear what's going on. So, shift, once again, dollar sign, and we can just say jump sound dot play. Cool. And it should only play once. Let's test this theory out. Will it work? There you go. Now we have a jump sound, but we haven't fixed the problem with there not being any music. To do that, we can't use the audio stream 2D because those play sounds relative to your, how do I say, to your proximity to it. To make a what application-wide song, use a stride audio stream player. This is the base audio stream node. Click on that. There you go. And now we go to music, tune, inspector, and just like the normal audio stream.2D, click, drag, and there we go. But we want the music to keep playing. To do that, we have to see if the song is finished. So, once the song is finished, we want it to play again. So, let's see. Oh, we also have to add a script to the level, or else we can't connect anything to it. So, add a script, level.gd, and click. Oh, no, not on the scenes. That's bad. Go to your scripts folder, then open, then create, and just like before, we get some basic code. I'll explain later what all of this does. Actually, right now, actually, yeah. Whoop. We just say this. If the audio stream the player has finished playing, you will simply just click and we will say audio stream player dot Dot. Wait, there might actually be a base autoplay. Yeah, autoplay. Oop, boop. Okay. When it's finished, we can just say dot play. Boop, boop, boop. And let's see if it'll work. Oh, wrong scene. Once more. Now, let's see. Will it loop? And there we go. Looping perfectly fine. So, now we have music playing in the background. We have detection for if the player comes in contact with anything and it will die. And we have almost a full game. All we really need now is a win condition and a lose condition. Simple enough, right? So, all we need now is to add the enemy and the coin. That will act as the win or lose condition. So, let's create a new scene. New scene. Uh, we have to add another character body, 2D, and we need to, let's rename it first to enemy, save, scenes, save, and there you go. Cool. Now, all we have to do is add pretty much all we had on the player. We need to give it a collision shape. A collision shape. We have to give it what? One collision shape. Animated sprite as well. Animated sprite 2D for the animations. So we have collisions and movement. But the enemy has to be given a primitive AI so that it'll actually chase the player, which is part of the fun. To do this, we will just use areas. Areas with a collision shape. But that'll come later. First, I want you to, by yourselves, I want you to both add the enemy sprites for each of the animations, and I want you to give it an appropriate collision shape. All right. I'll give you a few seconds to do that. Pause if you'd like, take as much time as you'd like, and when you come back, I'll do it for you anyway. All right. All right. Now, let's do as we did before. We go to our enemy tab and we can see our sprites. So, click new sprite frames, animation, click idle, our idle animation, add those, add another one, left, shift, click, add, and there we go. Animations added, simple as that. Let's speed this up to 10 to add a sense of movement. Let's slow the idle down to 3. And that is all the animations we need to add. Now, let's give it a shape, a collision shape. So, to save us work of actually changing the size of the enemy later, all we have to do is here and change it from here, 3. Now, he'll be 3 times as big. Oh, wait, that's just the collision shape. Not good. Set this to 1. Enemy collision, no, transform, and 3. Cool. Now we can actually set the collision shape. We again want to give the player some leniency. So we squish it down a little bit and like that. Maybe not too much leniency. We don't want the game to be easy. Part of the reason why games are fun is because they're challenging. All right. Now, we have almost everything that the scene needs, but we need the enemy to have a way to detect the player. That is a very, very important part. So, in order for the enemy to detect the player, we have to create another area 2D node. As we saw before, it detects anything that enters that area. So, All right, let us add just that. We can click Add Area 2D Node, and we'll call this Detection Area. On top of that, what we also need to do is create another collision shape 2D. As you saw before, the collision shape doesn't actually collide, it just acts as the bounds of the area at which the Area 2D node can detect something. So, we have a new Area 2D node. We don't have to name it, we can just simply click and let's give it a rectangular shape. So, let's space it. Ha and ha. So essentially, whenever the player enters this box, we want the enemy to react to that, which is not that hard, as I'll show soon. Okay, and on top of this, we want an area for when the player gets detected that we want it to actually say the player is dead. So we can actually shorten this collision to just do the necessary things it needs to do. We have to add a second detection area. So, pop area 2D, collision shape 2D, and first fix that. And we want to call this death area. And let's just give it a square box and make it slightly larger than the collision shape. Because again, we want some challenge, but we don't want the player getting away with bloody murder. So there you go. Now, if the player enters this area, they will die. Cool. We now have the very basics of the enemy finished. Let us implement the AI. Okay, cool. Add enemy, no, not on the scenes, bad, scripts, good, open, and finally, none of this. We can create an empty object because everything will be hand programmed. Anyway, all right, so welcome. So what we want to do is that whenever the player enters the death area, we want some way to communicate to the level or to the player that they've died. So there's something called signals. I'll call this player death. A signal is a custom method, you could call it, or a custom call. So if you click on our node to or enemy, here we see the player death signal. Whenever we collect it to, it'll prompt a death. So there you go. Later we'll connect this to the level node or even to the player node for them to see if they're dead. All right, nice. So we have that out the way. But just like before, we need to have a way for the enemy to move once it detects something. For that, we will still need a direction variable to see if they're going positive or negative x-axis. And to make things easier, we can create something called an export variable for the speed. So all an export variable is it takes this variable and makes it changeable within the inspector. See? Now, instead of having to go into the script, you can simply open the inspector and quickly change what you'd like to change. Okay, now let us create the essential movement. So we want something to run every single frame. So let's try and limit what we do. So physics, process delta, and that's all. So we have to add the most basic code here. All we want to run every frame is to change the enemy's direction and or movement. That is all we need to do. So we want to change if it's going left or right, which we use the dot x, is equal to the direction multiplied by the speed we've set, multiplied by delta, so it happens every frame. And remember before, the only way for things to move is if we give it the move underscore and slide default method. All right, that is all that has to go in the physics process. It is quite honestly the simplest thing we can do that'll work, and that won't bog down the game unnecessarily. It's small things, it's the small things that add up to cause performance issues. All right, now that is all we have to program manually by ourselves, really, or add manually without any assistance. So now we can actually get started on the AI. So go to the detection area, node, and just like we did with the boundary, you can click body entered, connect to the enemy, boom. Now, whenever the body enters the detection area, this will run. So let's start with our first line of code and my reasoning for it. If body.name is equal to the player or player makes sense. Cool. So the reason I'm doing this is that everything that has collisions is a body. And if we constantly are detecting all these other assets, this will cause us a lot of issues down the road. So there is another way to handle this. You can set the player's collision mask or collision group to a second group along with this collision shape, so that it will only detect anything on that physical second layer. So you can think of layers as layers of a cake. One layer can only be affected and not the other two, or layers in a paint program. You can draw over a layer and add another layer on top of it, and you won't affect the things below it. But for simplicity, I'll just simply make it that if it's equal to the body's name is the same as the player's, then the code will run. So the second we detect the player, we obviously want the sprite to move or the sprite to change to a movement sprite instead. So we will do dot play left. Awesome. Now we will set, now let's create a new variable. Var player is equal to character body 2D. This is to simply make it easier to manipulate values if we already assign it the correct type. Because any character body 2D variable will have a position, a velocity, and all those sort of things we need now to be able to program the AI. So player is equal to, or player is assigned to body. All right. Now, here comes the math. You might think it's complicated to make a simplistic AI, but it really isn't. It's the same as programming a switch in this case. If the position of the player within the world is on the x-axis is less than the position dot x of our enemy, that means if the player is left of the enemy, all we want to do is we want to set the direction to -1. And that's all we'll do. Direction dot play or direction will be equal to -1. Now, we also want to make sure that it's correctly flipped. But since we're going to the left, we can set the flip h to false. There we go. Now, otherwise, if the player's position, if the player's position is greater than the position of the enemy, we want the direction equal to 1. i.e. go to the right. And therefore we actually want to flip the sprite horizontally so that it'll move to the right instead. Awesome. Now that is the basic movement done. Let's try it out. Let's instantiate a new enemy into our scene. Instance, enemy, open, and let's move him all the way here. Let's just make sure he's sitting nice and right. And save, and let's run and see if our program works. Oh, and there we go. Now, the second we leave that area, well, he'll keep moving in that direction. That is what we have to fix next. When the player leaves this area, we want the enemy to stop and play its idle animation. On top of that, when the node is first rendered in, we want it to be playing the idle animation automatically. To do this, go to the script, and here is a new function that I haven't shown you before. The func, it's going to be called func underscore ready pass. So you've seen it before. The func underscore ready function or method is an inbuilt method that when a node is first rendered or a scene is first rendered in, that is the default state of the node. So all we want to do is when the node is loaded in, we want it to be playing the animated, we want it to be playing the idle animation. And there you go. Now we just have to say body exited. Cool. Once the player leaves the body, so if it's the body.name is equal to player, then oh wait, give me a second there. Okay, then we just get the animated sprite dot play the idle, and we just set the direction to 0. We don't have to do anything else to stop it from moving. And there you go. Let's test it out. We are actually starting to see the game come together, which is nice. From the beginning, we just had an image, and that was that. Now, look. We've entered it. Ah, he can't see us anymore. But we come back, he sees us once more. We jump over him, he sees us, up, 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 and there you go. Everything is working just as intended. Cool. All right, now. Finally, what we want to do is when the player collides or enters the death box. This is the final thing we have to program for the enemy for it to work. So, back to the node. Oh, what has happened here? Oh, never mind. Ah, here. Okay. On body exited. All right. That means once a body leaves that area, if oh wait, no, sorry, wrong one. Haha, we want to disconnect that. If the body entered, connect, and just like before, we can just copy, Control V. We simply just want to emit that signal, that death signal we have. Dot emit. Awesome. So now, whenever the enemy or the player collides with the enemy, we wanted to emit the death signal. Now, let's implement it. So, let us go into the level scene, click on the enemy, inspector or node, and click on player death, connect onto the level or onto the enemy. It works either way. Now, I just want to show you how groups work. So, we can just say, now, all we really have to do is press get underscore tree dot call group player, the player group we created, comma, and what did we call the death function? player. We just simply called it death. So go back to the level and write death. So it'll run the death function for us. Awesome. Now let's try it out. Will it work? Will it won't? That's the question. Let's see. Now let them touch us. We died. There you go. So we have a functioning game. Isn't that great? Pa, 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 pa. Now we just have to add the coin, the win condition. And we are almost finished. That close. So let's create a new scene. And instead of the whole, now we can just create a sprite because we don't have an animation for the coin. We can add an area 2D and we can add a collision. We'll just rename this to coin. And there you go. We are almost finished. So, all right. Let us go to the 2D. And finally, let's give it, let's first give it the coin, collectibles, coin, click, drag, drop, set it to 4 times what it should be, or 3 times, I apologize. Collision shape, empty, set it to a circle, whoop, and there you go. That is our coin, made perfectly. Save. And the coin will have, honestly, it'll have 2 important functions. We'll also add audio, add, because we want audio to play once we collect the coin. We will simply add the pickup coin, boop, and okay, awesome. Now, let's add a script. We will not put it there, bad, go script, and open. Let's create an empty node because we don't want it to have anything except it being empty. So we want it to, for when the player collects the coin, that the player will win. That's our win condition. Okay, now we have to show that when the coin is collected, that we simply want the coin to disappear and we want the sound to play. So what we have to do, area, body entered, body entered, connect, once more, we can do that. We want to audio stream player dot play, and we want to signal, we want the win dot emit. Finally, we want eventually, see, if you delete or free an object here, it'll immediately get rid of it and the audio won't have a chance to play. So to queue free safely, users do dot finished, connect, then delete. And only once it's finished playing can we say get underscore free. Or queue free, not get free. Queue underscore free, which will free the current node, i.e. delete it. So let's do that. Let's add the coin to our level. Coin, instantiate, coin, pop. Oh god, it's massive. So overcompensate a bit. Let's just set that to 1. 1 and 1. Still massive, but what can you do about it? All right, now let's see. Will it work? Wrong seed. Same mistakes, never die. All right. Enemy moving, enemy stopping. Jump, jump, jump. And there you go. Now we just have to show the player that they've won. All you really have to do is create a user interface. So let me introduce you to user interface. You could simply add a label as a child of the player node within the level, but I want to show you this at least. Let's just call it win screen and add a label, which is part of the control, or, well, UI is called control in Godot. We just simply write win, that i.e. win condition, and we can edit the text however we'd like. To actually change the size of the font and everything, you can go click here, click new label settings, and then font. We can set the font to a gargantuan size to just emphasize how much of a winner the player is. We can center this somewhat. Let's use some anchors, center it perfectly. Color, let's give it a blue purple tinge. And there you go. Now, windscreen.tcsn, and let's set it as invisible by default because we only want it to show up when the player wins. So go to process, visibility, off by default, and now go to the level, instantiate, let us go to the win screen. Now it'll show up where exactly? Where has it gone? Oh, it's off by default. So just for the sake of seeing it and putting it where it needs to go, yeah, it's in the center. Cool. Now all we have to do is now we can link the coin's win condition. No, so yeah. Okay. Now we just connect the win condition to the level, and now whenever that happens, you just get win screen dot visible will equal true. And that should be a full game. Let's test it out. Never mind, you've lost. Jump, 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 jump. And let's collect that coin, baby. And you win. Look at that. And that's that. That is that. Congratulations. You've made your first game. Given, very simple and primitive, but you've made it. Take this as how you should, don't take this as how you should make a game, but more as an explanatory lesson on how the Godot game engine works and how the different parts of the Godot game engine work, from scripts, nodes, scenes, and how they all work together to form complex mechanics and systems to make a somewhat fun experience. I encourage you to add upon this, change it, do whatever you'd like, fix my code, make your own code, add new features that I haven't explained in this tutorial, add new nodes that I haven't explained in this tutorial. Do whatever you'd like. Now, happy game making and unleash that creative drive onto the world.